Welcome to the massive open online course Modeling Urban Ecosystems. I am Dr. Vyacheslav Vasinyev and I will be in charge of giving lectures and seminars within this course. I am Associated Professor in the Department of Landscape Design and Sustainable Ecosystems at Ruden University, also the Chair of the Double Diploma Management and Design of Urban Green Infrastructure, and the Head of the International Summer School Modeling, Management and Monitoring of Urban Soils and Green Infrastructure. Our department is interested in studying and investigating urban ecosystems, soils, green infrastructure. My personal background is soil science. I graduated from Moscow State University and defended PhD in soil science and environmental science, and afterwards obtained doctoral diploma in Wageningen University, focused on the urbanization effect on urban soils with the main interest in the social and environmental consequences of urbanization. My colleagues would assist me with given practical tasks within this course. They are Dr. Kristina Ivashchenko with the main focus on microbiological analysis, and she will be in charge for the practical tasks in statistical modeling. Ms. Olga Ramzaykina and Ms. Irina Vertelnikova, with a strong background in GIS and spatial analysis and modeling, have prepared for you interesting case studies in spatial modeling and spatial analysis with a particular focus on remote sensing techniques. And Dr. Alexey Yaroslavtsev will give a strong background and has strong focus in process-based modeling. We also gain some help and assistance with our external colleagues and partners, who are Professor Andrei Smagin from Moscow State University. He has provided an interesting case studies on mass water energy transfer models and examples and manuals from the Hydros model. Dr. Pavel Konstantinov from Lomonosov Moscow State University Geography faculty would give some feedback in climate modeling and particular cases in the heat island modeling. Dr. Jetse Strufogel from Wageningen University will share his huge experience and land use change modeling. And finally, Dr. Carlo Calfapietra from Research Council of Italy will share experience in green infrastructure modeling and a particular case study of I-tree model. The duration of the course is 6 weeks, and it will contain 6 models, including 6 lectures, video materials, practicals, seminars, and additional didactic materials. Here you can see the content of the course. The first model is Introduction and general overview of the urban modeling, goals, challenges and perspectives. The next model will include particular cases of water, atmosphere, soil and green infrastructure modeling for the cases of the urban environment. Then we are going to discuss several aspects of approaches implemented for urban ecosystem modeling. Model number 3 would be about statistical model, starting from the basic data analysis and continuing with correlation, regression and determination analysis, analysis of variance, and the ways to implement those approaches to model urban ecosystems. Then we are going to move to Model 4, which is the spatial models, including different GIS approaches and geostatistical approaches, extrapolation, interpolation, and the specifics of these approaches to be used in very heterogeneous urban ecosystems. Afterwards, model number 5, it's kind of continuation of the spatial approaches, but with the main focus on remote sensing. We will talk about the sources of the remote sensing data and perspectives of these remote sensing techniques to model urban ecosystems. And finally, model number 6, from my point of view, one of the most interesting and applicable, because there we are going to overview and test already existing models and their applications for urban ecosystems. We'll talk about different process-based models, like for instance I-tree, Hydros model, EDIPRO, and other model utilities and model software which are applicable for the urban ecosystems. Each model contains of the following parts: the video lecture of 20-30 minutes, the didactic materials, a chapter and an e-book, which you are very welcome to read after the lecture and between the lectures, and practical case studies where data and the methods for those we are going to introduce at the end of the current lecture. Here you can see the literature sources I could recommend you to follow within this course. They could be subdivided in several books. For instance, two last ones are with the main focus on urban ecology. However, they contain specific chapters on modeling urban ecosystems, which is quite rare information. Some others, like Open Intro Statistics, they are focusing on the specific approaches used for modeling: statistical modeling, spatial modeling, process-based modeling. And as a separate but also very important sources, I would recommend you to read the manuals and descriptions of the particular model and software. We're going to use several types of the software, and we will focus on the open source software available for free for any user. Mainly this would be the R project, R language used for statistical and geostatistical analysis, and you can download the manual on R from the website. And another source is QGIS software, which is the GIS program, also open software, which we'll use for spatial analysis, extrapolation and interpolation technique, partly also for the remote sensing. The models we are going to deal with, the models already exist, including commercial models such as HYDROS 2D, 3D model or EDIPRO model. They also have manuals in different languages, but mainly in English, which you are available to download and read. So I believe that these sources, including the additional information I would refer to, for instance some papers describing the modeling cases, would be more than enough for you to follow the course. What is this course about? During the course we are going to address several research questions which are probably could be aggregated in those you could see on the screen. First of all, of course, we'll talk about what is this specific and particular about urban ecosystems as a modeling object. What are these features, processes and mechanisms and driving factors we are going to consider when dealing with urban ecosystems. An important question, of course, is the data problem, because the data is always necessary to fit, calibrate and validate the model. So what the type of the data do we need, where to take the data and how to use this data is another question we are going to address. What are the demands of the decision makers and other users for modeling urban ecosystems, because each type of the model has its user, and actually when modeling we should consider the particular interests and the particular outcomes. So we are going to analyze what are the demands for the modeling and how the model could fulfill this demand. So again, what should be the drivers, what should be the assumptions, what should be the outcome files. And of course, the question, which again I guess would be quite interesting for the broad audience, what are the specific types, what are the examples and case studies of the models already implemented for urban environment. It also must be mentioned that in comparison to other more classical, more conventional courses on modeling, where you normally have a lot of calculations, maps, algebra, mathematical equations. Here, of course, we'll have some of them, but still we are going to give the main focus to modeling urban ecosystems from the perspective of the model user, not a model developer. And that's why this course would be less theoretical, more practical. We're going to overview a huge amount of models and modeling approaches used for urban ecosystems and select the best ones which we could recommend for your further studies and for your further analysis.